Okay, here's warm-up 4.8. I'm going to start off with a parabola. This is a quadratic equation. We're going to find the vertex. So the vertex, you can take the contents of the parentheses and set it equal to 0. And then solve for x. So I'd add 3 to both sides. That means the x-coordinate of the vertex is 3. The y-coordinate is going to be whatever is added or subtracted to the end. This is when we're in vertex form like this. So my vertex is going to be the point 3, -1. Okay, so I'm going to go ahead and plot that for part C. So 3, -1 goes right here. That point is not going to move. That's my vertex. Okay, so put a little V by there so I don't forget to not move that. Okay, and then describe the transformations. Well, from the parent graph has a vertex at 0, 0. So this vertex, new vertex, represents, we've translated 3 right, 1 down. So the whole parabola is going to go 3 right, 1 down. Okay, you could say translated 3 right, 1 down, but I'm just going to say 3 right, 1 down. Okay, but then we've also got this 2. So this is going to give me either a stretch or compression, or you can say shrink instead of compression. So a stretch or a shrink, or a stretch or compression, however you want to say it. Okay, so the way I think about this, I know that 2 is going to make this 2 is going to make my graph narrow. It's going to make my parabola look narrower. Okay, and then I'm looking at the placement of it, and I want to figure out if this is a horizontal or a vertical change. So if the 2 were inside the parentheses, like it had 2x inside the parentheses, then it would be a horizontal change. It would be multiplying the x directly. The x-axis is the horizontal axis. It's on the outside, so this is going to be a vertical change. Okay, so if this didn't have, my parent graph shape would be like this. This is not what the actual parabola is going to look like, but I go up 1 to the left and right 1, and then I go up 4 to the left and right 2. So if there's no stretch or compression, that's what my parabola would look like. Okay, so now I know that this is going to be getting narrower with a vertical change. So these points can only move up or down. So if they move down, it's going to kind of open up the parabola and it would look wider. If they move up, it's going to close up the parabola and it will look narrower. And that's what I want to happen. I'm going to move all of these points up from where they are right now. Okay, and so that means this is going to be a vertical stretch. Okay, so that's my other transformation there. I got translating to the right, 3 right, 1 down, and a vertical stretch. Okay, and then since this is a 2, I want to double the height of those points from the vertex. So these first 2 points are 1 unit above the vertex. I want to double that. So just moving up 1 from where they were. Now that height is doubled. These points are 4 units above the vertex. So 1, 2, 3, 4. I need to go up another 4. 1, 2, 3, and off the graph that I provided a little bit. Oops. But we still got enough room there to get that done. Okay. And then I can graph this. Okay, and there's my my graph. Now, this is a very similar equation. It's just cubic instead of quadratic. Okay, so we've got a new parent graph. So you have to know what the parent graph looks like. So I'm making a little sketch, a very simple sketch, but it's going to be an S-curve that looks something like that. Okay. All right, so let's find the center. We do that in the same way. So my x is going to be 3, and my y is going to be -1. So my center is the point 3, -1 again. Okay, so let's go ahead and plot that, 3, -1. Then I'm going to put what it would look like if there was no stretch or compression. So I'd have this kind of a shape, right? So I'd go up 1 to the right 1 and down 1 to the left 1. Okay, I'm also going to just remind myself that this is the center. And I'd have an S-curve, but I don't want to draw it in yet because I want to put in the transformations. So just like before, we're going 3 right, translating 3 right, 1 down, because that moved the center. And just like before, we're going to have a vertical stretch for the same reason as the parabola there. Okay, so there's my transformation. So let's do the vertical stretch. So I want to double the vertical distance from the center. So that means these points can only move up or down. And, you know, this one's going to have to move up to go away from the center. This one will move down. So I'm going to double the height of those. So it's going to be there and there. Okay, and the next set of points would be off the provided graph. So I'm just going to stick with those. And then we get an S-curve. And the center is the center of the S. Okay. All right, that's it for the warm-up, and I'll see you next time.